Lesson 4-4, graphing functions. This is what I think about when I think of algebra. I am so excited that we are finally at this point. We're going to skip the vocabulary because I'm not going to put too much emphasis on those words that they gave you. The main point from this chapter is not really all that new. It's that you can take a function and represent it with a graph. We've kind of been doing that. So we're going to get a little more practice. Given this function, y equals negative 2x plus 1, what does the graph look like? Well, step number 1, make a table. Here's your x, put it in the function, and then they gave you the ordered pair. Your y is 3. Pick another x, any x, put it in the function. The y that that function generates is a 1. Notice that they chose some positive, a negative, and 0 so that they would get a good mix of numbers. And then they just plotted the points, negative 1, 3 right here, 0, 1 right here, 1, negative 1, and 2, negative 3, and drew the line. Not very hard. Take a look at got it number 1. Give it a try. So I'm going to tell you right away that it's very late at night, and man, if I'm ever going to make a mistake in the video, tonight's the night, so pay good attention. Problem number 1. Here's the function they give you, y equals 1/2 x minus 1, and they want to know what the graph of this is. Well, step 1, make a table. And I put in a whole mess of points. This x, put it in the function, gives you this y. Do I expect you to do this many points every time? Not exactly. For the moment, 5 is plenty. Make sure that you try 0. Make sure that you try at least one negative number. Go ahead, check my math really carefully, because who knows what I've come up with tonight. Take the x, plug it into the function, and the answer that you get creates your y value. So you are generating ordered pairs. 1, negative 1/2, 2, 0, 3, 1/2, 4, 1, and so on. Once you've generated a number of pairs, then you are ready to make a graph. Now, this is going to be really hard for some of you because it requires you to be very neat. And writing small is a good thing. If you can't write small, then you need to make your graph really big, one way or the other. But you need to space your numbers evenly on the graph, whatever your scale is, and I need to be able to see where your points are, and it's just got to be as legible as possible. So these points are all right from my table. So when x is 1, y is negative 1/2. X is 1, y is negative 1/2. And you check my line, because like I said, I'm tired tonight. Who knows what's going to happen? Last chapter was all about linear or nonlinear. Look at that. All those points line up. This is a linear function. And that's all there is to problem 1. Turn the page. With problem 2, they're using a whole lot of words and big numbers, which I think makes the issue more complicated. They're asking about real-world functions, and they've given you a function that has to do with the weight of a concrete mixer truck that carries c cubic feet of concrete. Basically, the point they're trying to get at is, can the weight be 0? Can the amount of concrete be less than 0? So, of course, no. You can't have a negative weight on a concrete mixer, at least not in this universe. So what they're saying is, for this one, on your table, only put in positive numbers. They're also saying, think about the weights. How silly would it be if you put 1 cubic foot of concrete in your 30,000 pound concrete mixer truck? So use bigger numbers. If it's empty, the truck weighs 30,000 pounds. If you put in 50 cubic feet of concrete, that's how much it weighs. Now, there goes my dog again. I'll be right back. Okay, Reggie says thank you for not minding the interruption. Now, similarly, after you've plugged in logical numbers for the function that you have, look at the graph. We didn't start at 1 or 1/2. We've got huge numbers here. Our x-axis is going up by 50s. Our y-axis is going up by 20,000 pounds at a time. So when they are talking about a real-world function, they just mean think about what numbers make sense. Give that a try on Got It number 2. We are talking about the weight of a hot tub that contains gallons of water. So before you start plugging numbers in, think about what makes sense, and I will be ready when you get back. So here's the function they gave you. It says W equals 8G plus 700. Why did they use W and G? Because they're talking about weight and gallons. I kind of wish they'd made it a little more straightforward. We're dealing with plotting this on a graph, so we need to know the X value and the Y value. How do I know that this one's X and this one's Y? Because this is your independent variable and this one is the dependent variable. So ponder that for a second. Go back to the last unit, not last unit, the last lesson, if you can't remember dependent and independent variables. And so now you need to make a table. That is step 1. Now, in my defense, remember I said it was late. I went through, oh yeah, easy, I'll just plug in a few numbers. Y equals 8 times 1 plus 700. Put 1 gallon in. The hot tub weighs 708 pounds, and 2 gallons, 716 pounds, and so on. And then I came down here, and I thought, do we need negative numbers for this? Can you put negative gallons of water in your hot tub? Well, again, not in this reality. Maybe in another one, but not this one. So then I went to graph this. And I thought, okay, 1 gallon, 2, so on. And then, well, my numbers go from what? 700 if I put in 0 gallons of water to 724 if I put in 3 gallons of water. And I was trying to make this graph look right, and it just wasn't working. And then I went, oh, you knucklehead, who's going to put 1 gallon of water in your hot tub? That's not even going to get your pinky toe warmed up. So I started again. You guys are smarter than I am, though, so you're going to benefit from my mistakes. And I put in 100 gallons and got that Y value of 1,500 pounds, and so on. Once I did this, a more real-world logical set of numbers, then my graph looks like that. And now that I have chosen better numbers, my graph makes much more sense. And I can connect this line. Notice I only drew the first quadrant of the graph because, like I said, we can't put negative amounts of water into your hot tub. So don't worry about the other 3 quadrants. At least that's a nice break. So on page 255, they're talking about the vocabulary words that I told you guys not to write down. We are going to cover them, but I'm not going to quiz you on them, so don't write them down. A continuous graph is an unbroken straight line continuing off into either direction to infinity, all connected. A discrete graph only has specific points. What is the difference, you say? Well, unfortunately, they went on to give you some crummy examples. This example of a continuous graph is good. They're saying that a gallon of milk makes 16 ounces of cheddar cheese, and if you change the numbers, can you have partial gallons? Can you do a half batch or a double batch or 3/4 of a batch? Yeah, sure you can. You can put any amount of milk in and you will get a reasonable value for an amount of cheese that you make, or the weight of cheese. So that one gets a line. Then I didn't like the discrete graph example because they were talking about how you could only sell a full wheel of cheddar cheese. And I think I've just been working with you guys for too long because I could just hear Ben saying, but what if I only want 1/4 of a wheel of cheese? And so I knew that this example was not going to work. If they had included the word, you can only sell 1 full wheel of cheese, then I might not have a problem with it. But at any rate, supposing you could only sell a full wheel of cheese, they're saying this one only gets dots. because you can't sell half a wheel of cheese or 3/4 of a wheel of cheese. It gets better on the next page. Got it, number 3. I don't want you to graph each one. I just want you to figure out if they'd be continuous or discrete. Just think about it. The amount of water in a wading pool depends on the amount of time the wading pool has been filling. Is that going to be a continuous line, or is that going to be specific dots? And letter B, baseball tickets. What's your graph going to look like for how many dollars you spend gives you how many tickets? Think about it. Come check your answers with me. Well, letter A, does it make sense to have fractional gallons and fractional minutes while you're filling a wading pool? Sure, you can turn the hose off after 90 seconds or 35.5 minutes. And yeah, absolutely. So this one would be a continuous graph. Now, does it make sense to have fractional tickets? Can you imagine going to a Phillies game and saying, I would like 2.75 tickets, please. I'm going to bring myself, my best friend, and 3/4 of my brother. That makes no sense. You could have fractional dollars, but not fractional tickets. This is a good example of a discrete graph. Moving right along. Problem 4 is just a little more practice with what we've been doing, except they're telling you that these graphs are nonlinear before you start. They're giving you a function, you're going to make a table, and then you're going to plot it. Now, because these are nonlinear, I need you to use 5 different points in your table when you get to got it number 4. Give it a try. So I made a note for you here. Do not forget to use 0 and negative numbers when you are plotting these graphs so that you get a good idea of the whole picture. Here's your function. Make sure you have it written down somewhere so we know what it is. Y equals x cubed plus 1. You must have a table that's showing me x values, y values. Here's your math. 1, 2, 3, 4. I've got 5 different values. Once I've got that done, do a graph. And again, make sure it's neat. Make sure I can read it. And you plot your points. Here, here, here. Check my work, because, you know, I told you. Tonight's the night I'm going to make mistakes. And you know this is nonlinear, so you know it's going to be a little curvy. Try to make it as smooth as you can. Again, not necessarily an artist. That is kind of what that graph looks like. Now, I feel like generating these tables takes a little bit of time. So while I want you to do the lesson check on page 257, I only want you to do 1 through 4. Don't worry about the rest of it. Take the rest of the day off.